In example 4, we have the same type of question where the limit of x minus 2 divided by x squared plus x over 6, plus 6, but as x is approaching 2, the only difference in this example is that they don't give us any of these x values. So it's our job to first create this table, and then after we create the table, we have to fill in the table and then estimate the limits. All right, so as we fill in this table, the 2 goes in the middle. What we're approaching goes in the middle, and then from there we extend farther away from 2 in both directions. So in the positive side, we would go 2.001, then 2.01, and then 2.1. Those values will be getting farther and farther away from 2. And then same thing on the negative side, or on the left side of 2, 1.999, 1.99, and then even farther away would be 1.9. All right, now it's our job to fill in these function values. So I've gone ahead and done those already. When I plug in 1.9, I get negative 0.0089, 0.0008, and then 0.00008. And when I plug in a 2 this time, I actually get a value. I get 2 on top, and I get, 4 plus 2 plus 6. We get a 0 on top, and then 12 on bottom, and 0 divided by 12 is in fact 0. So the function value there is 0. I'm going to plug in a 2.001, I end up with 0.00008, 0.0008, and 0.0079. I made a mistake. These guys over here are actually negatives. Okay, so from the left side, as my x values get closer to 2, from the left side or from the negative side, you can see that the limit as x approaches 2 from the negative side is getting closer and closer to 0. These values are getting closer and closer to 0. From the right side, or from the positive side, the limit as x approaches 2 from the positive side, you can also see that these values are getting closer and closer and closer to 0. And because those are equal, we can say that the limit as x approaches 2 in general of this function is in fact 0. This is a little bit different of a case where the limit is actually the same as the function value. In this case, the function value is 0 at 2. The limit is 0 at 2. Okay, so at this point, pause your video. Go ahead and work on examples 5 and 6. And when you have finished, unpause to see the solutions and check your work. All right, so in example 5, as our x values get closer to 0 from the left, our function values appear to be getting closer and closer to 0. So in this case, limit as x approaches 0 from the negative side appears to be 0. From the right side, as our x values get closer to 0, our function values get closer to 0 as well. So the limit as x approaches 0 from the positive side would be 0, even though the function itself at 0 is undefined. The limit is what they're getting closer to. So finally, the limit as x approaches 0 in general, because these two things are the same, then that would be also 0. And for number 6, from the left, our x values get closer to 1. Our function values get closer to what appear to be 2/3. So the limit as x approaches 1 from the negative is estimated to be 2/3. From the right, as our x values get closer to 1, our function values get closer and closer again to what appears to be 2/3. So therefore, the function value in general, as x approaches 1, of this function is 2/3.